Hello there. Let's talk about graphs and whether they're connected or not, or maybe whether they're strongly connected versus weakly connected versus not connected. You never know. Okay, so hopefully you've seen my previous videos by now, where we just talk about the basics of graphs. I have like a blank sheet of paper here. I'm just going to start drawing a graph. Remember, graphs are nodes and edges, where the nodes are like little T-type data structures that can hold a specific type of value. So I'm going to say our nodes hold integers. I think I made that one too small. That's okay. And the edges could have weights or maybe not weights at all, depending on if you have a weighted or an unweighted graph. So I'm just going to start duplicating my nodes a little bit. And I'm just going to make a random graph. I need to probably change these values. Technically, your graphs should support duplicate values in the nodes, but and also the weights. But I don't want to because it's easier to talk about the graph when all the values are distinct. So for starters, we have a bunch of nodes and they're not really connected to each other. Is this a valid graph? Yeah, it is. It's just not a connected graph. So the terminology that we're going to use for undirected graphs, meaning the edges don't have direction, is going to be connected or not. I usually just say a not connected graph or a disconnected graph. So just basically like connected or not connected. Okay, so this is a not connected graph. I'm going to say not connected. Not cinnamon. I'm thinking about food as usual. So it's not a connected graph. Why is it not a connected graph? Well, to define what does it mean to be a connected graph, it just means that every single node can find a path to every single other node in an undirected graph. So we can just double check this real fast. We can say, can node number 2 find a path to, let me put a question here. Let's say we're going to check. You should be checking all the nodes one by one to see if the node in particular can reach every other node. The first node that can't do it means the whole graph is not considered connected. So, 2, it can't reach 1, so that means it's not a connected graph. So this is not a connected graph because one or more nodes violate the rule of you have to be able to reach every single other node. Okay, so that means if we want a connected graph, we probably just have to start adding edges. So I'm going to go ahead and let me write the word connected here, and then I can like either circle it or cross it out. So right now we have, no, this is not a connected graph. I'm going to start adding edges. We're going to stick with an undirected graph for now. So I'm going to connect 2 and 1 and 2 and 9, maybe 1 and 13. Actually, you know what? I'm going to erase this edge and maybe connect these over here. And the thing is, this is a valid graph that you're looking at. It's just not a connected graph. Some other terminology I didn't mention in other videos is that we can have subgraphs. We have like a subgraph here and another subgraph here. Those are basically just two different portions of the same graph that appear to be connected within themselves. So those are subgraphs. You can probably tell right away that this is not a connected graph. You can double check to be sure. It's good to do things the hard way so you don't get the wrong answer when you're really trying to figure something out. So let's look at 2. Can 2 reach 1? Yes, so that's good. Can 2 reach 9? Yeah, it just hops to 1 and then hops to 9. So 2 can reach 1 and also 9. That's good. Can 2 reach 3? Nope. So this is still not a connected graph. Okay, I'm going to add one more edge, and then we'll just check again. Where do you think I'm going to do it? Maybe if I add, I'll add a funky edge going from 13 to like 9 or something, just so it feels a little bit more awkward. Okay, let's check one by one. Let me actually get rid of this edge on the previous slide so we can still say that's not connected. Let's check one by one. Every node must be able to reach every single other node. So I'm going to look at 2 and I'm going to say, all right, 2, can it reach 1? Yes. Can it reach 9? Yes, we go from 2 to 1 to 9, so that's good. Can it reach 3? Yeah, it can go from 2 to 1 to 9 to 13 to 3, and then it can reach 3. And because we just saw that it went through 13 to reach 3, that means 2 can reach every single other node. This is going to be more important as a double check when we have directed graphs in a second. So 2 is good. So the next thing you want to do is just move on to some other node and do the exact same process. You know, can 9 reach a 1? Yes. Okay, it can reach a 1. Can it reach a 2? Yeah, it goes through the 1. Can it reach the 13? Yep. Can it reach the 3? Yep. Okay, so we just checked every single destination node starting at the node 9. But here's a little bit of a shortcut. Try to find a node that is right next to a node that you know can reach everything. And if the node in question is able to reach that previously, connected node or vertex, then we know that that node in particular is also connected. So what I'm saying is the 1, instead of checking every single other node in the graph, which might be really hard if we have a whole bunch of nodes in our graph, we'll just ask, can the 1 reach the 2? Because if it can, the 2 can reach everything. So that means the 1 actually can reach everything as well. So the 1 can reach the 2, so the 1 is connected to everything. The 3 can reach the 1, and the 1 can reach everything. I'm doing things the hard way on purpose just to prove a point. So the 3 can reach everything. The 13 can reach the 3 in one hop, so the 13 can reach everything. The 9, it can reach the 1, and it can reach the 13 in one hop, so the 9 can also actually reach everything. So that means this is indeed a connected graph. Yay, we did it! Sorry about that. The next thing that we're going to do is add direction to our graph. We could do like more examples. Maybe leave a comment if you want me to do some super extra complicated examples for just an undirected and connected graph. I'm ignoring weight, by the way, because it doesn't really matter for these purposes. So let's upgrade our graph. So maybe I should put a question mark here. That would have been a good idea. We're just asking, is it connected or not? I'm going to take this existing graph and I'm just going to start adding direction to every single edge. Let's see if I'm following my notes. Single node, subgraphs, right? Well, it wasn't connected at first, and then we started adding. Okay, so that's basically okay. Let's add direction to every single edge. So every single edge has to have a direction, or every single edge has to have no direction. You can't really mix and match. So I'm just going to go through every single edge and add a direction like this. And to be fair, I think I've said this in my other videos, an undirected edge is kind of the same thing as a directed edge going in, or 2 directed edges going in both directions. So this 3 and 13, what's going on with my computer? Hello? This 3 and 13 edge, it would have kind of been the same as just having 2 edges going in opposite directions. So maybe I'll just do that right now. For this huge, weird edge, I'm just going to put like an arrow over here instead of totally redrawing it. Then I double check that every single edge has a direction so that I have a valid graph. And now I can ask, is this connected or not? Actually, when it comes to a directed graph, you don't really have connected or not anymore. You have strongly connected versus weakly connected. Maybe I should just separate these words and then just kind of like move them. So let's get rid of this. Save this over here, move it down. So what am I talking about? Well, first, let me remove an edge real quick. I'll remove this edge right here. So now we have 2 subgraphs in this graph. You can tell for sure if this was an undirected graph, it would not be connected. But now that we're dealing with direction, we have to ask, is it strongly connected versus weakly? So what does strongly mean? Strongly connected means, can every node reach every other node if you obey the direction of the edges? So that's clearly not true. There's no edge at all that even connects this 1 and 9, so it's definitely not strongly connected. Weakly connected, on the other hand, means if you temporarily ignore the direction of the edges, then could you consider the graph connected? So if we pretended that there were no arrows here, would we think that it's a connected graph? If the answer is yes, then it's at least a weakly connected graph. So this is not weakly connected, because if this was an undirected graph, it's not even connected at all. So that sucks. I'm going to go ahead and add another edge here. So I'm going to add an edge from 2 to 9. So the first thing is, sorry, I have to add another edge. Let me do from 1 to 13 for fun. So now the first thing is, let's check to see if this is a strongly connected graph. Right away I can see that the 2 node is unreachable by any other node. So this is definitely not strongly connected, because all the other nodes would have to be able to reach 2. All right. So first thing you could do just to very quickly check is just look at every single node and ask, is it reachable, by anything? And then after that, you can do things the hard way. So it's not strongly connected. What about weakly connected? If we ignore the direction of the graph, if we ignore the direction of the edges in this graph, then yeah, we could reach every single node from every other node. Let's just double check that real fast. I'm going to say, the 2 node, if we're ignoring a direction, can it reach the 1? Yes. Can it reach the 13? Yes. The 3? Yes. Can it reach the 9? Yes. So that means the 2 node is sort of like weakly connected to every other node in the graph. Do the same thing for the 1 node. Previously, we just said, check everything one by one or use a shortcut. So I'm going to use the shortcut. The 1 node, if we ignore direction, can reach the 2 nodes. So I'm going to say the 1 is weakly connected, at least to everything else. I'm not even going to check to see if it's strongly connected to everything else. I think the answer is no, but we do the same thing for the 13. The 13 can reach the 1 pretty fast. The 3 can reach the 13. The 9 can reach the 2. So every single node can weakly reach, that's not an official term, every other node, which means this is a weakly connected graph. Okay, cool. How can we make this a strongly connected graph? Well, we just have to add a bunch of edges. So that's what I'm going to do. I'm going to kind of like look at what is missing here. So we'll ask the 2. Can the 2 reach, and let's obey the direction of the edges again. Can the 2 reach the 1? Yes. Can the 2 reach the 13? Yes. Can it reach the 3? Yes. Can the 2 reach the 9? Yes. So that means right now the 2 is strongly connected to everything else. So we're on track for a strongly connected graph. We then look at the 1 node and we realize that the 1 node, it can reach the 13 and the 3, and it can also reach the 9, but it can't reach the 2. That's one thing that was blocking us last time from saying strongly connected. So we just have to add another edge if we want this to be a strongly connected graph. We have to figure out how can we get the 1 to reach the 2. We can go through something if we want to. That's fine. We can also just write an edge that just goes back to the 2, but that's, I don't know, that's kind of boring. I'm going to make an edge that goes from 1 to 9, and then I'm going to make an edge that goes from 9 to 2. So looking at the 1 node, it can now reach the 2 if we go through the 9. So that's good. Can the 1 reach the 9? Yes. Can the 1 reach the 13? Yes. Can the 1 reach the 3? Yes. Okay, so the 1 node can now reach every single other node. So now we're a little bit more on track for a strongly connected graph. Look at the 13 node. Can it reach the 1 node? Actually, yes. If we go from 13 to 9 and then 2 and then 1, we can reach the 1 node. Since we know the 1 node is connected to everything else, we can now say that the 13 node is connected to everything else too. The 3 node is connected definitely to the 13, so I'll say 3 is connected to everything. The 9 node can reach the 2 node, which is connected to everything, so that means the 9 node is also connected to everything. And at this point, we now have a strongly connected graph. It's not weakly connected, it's stronger than that. Any questions? So let's see, we added a bunch of edges. I think maybe this is actually all we need to do for this particular video, because we're just going to talk about connectedness. About 15 minutes, not too bad. All right. So I think I'm going to leave it here. Drop a comment if you want to do way more complicated examples. If you want to provide me a sample graph, that's awful. And I could just, I don't know, sometime in the future, I could record a video about it. Or just let me know your thoughts. Thank you so much for watching this video. I hope you had a little bit of fun, and I hope you learned a little bit of stuff. I'm outie. Patouty. All right, let's see. We're going to do this. Whoa. Can you see that guy in the background? Oh, shoot. I'm just kidding. I set that as the screensaver. Hey, everybody. Thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos, or just I'll be able to keep making videos in general. So please do do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video, and it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all. Am I recording? Yeah, I think I'm good. Okay. Hello there. Let's talk about whether a graph is connected or not, or maybe whether it's strongly connected or weakly connected or not connected at all. You never know.